Hello fellow explorers, this is Tony Tapia, and today we're going to be talking about the past, the present, and the future of space exploration. So the earliest practical work on rocket engines that were made for space exploration happened towards the early 20th century. On October 4th, 1957, the Soviets launched the very first satellite called the Sputnik 1 into space, and that's this image right here. It is roughly the size of a beach ball. 4 years later, on April 12, 1961, Russian Lieutenant Yuri Gagarin became the very first human to orbit Earth in the Vostok 1. And that's that image right here. Now, studying our solar system has been happening since ancient times. In the 3rd century BC, a heliocentric model of the solar system was created by Aristarchus of Samos, and that's this image right here. Identifiable stars and constellations also appeared in writings of early Greek literature like Homer and the Odyssey. Galileo Galilei studied the sky through telescopes in the 1620s. More recently, or presently, through the technology advances through the years, we do definitely have a greater, more in-depth knowledge of planets in our solar system. We now know things like the planet mass, the length of the planet days, and the density, and so forth. For the future, I think we'll probably kind of go into more of the origins of planets and find out how their climates have changed, and also maybe even a definitive reason as to what caused planetary tilts in some planets. So first off, what's remote sensing? Remote sensing is essentially used to describe the science or art of identifying, observing, and measuring an object without coming into direct contact with it. In 1946, V-2 rockets were launched into high altitudes from the White Sands, New Mexico area and took pictures as the rocket ascended. In the 1960s, astronauts took photos from the windows of their spacecraft. Today, there are all types of methods used in remote sensing, but essentially there are two main types, which are passive and active. Passive remote sensors are instruments such as radiometers, spectrometers, radar, and so forth. And in this GIF here, you can actually see an example of an active remote sensor. Active sensors provide their own energy source for illumination and emit radiation directed towards the target to be investigated, and then the radiation is reflected back and measured by the sensor. Now, the future of remote sensing is really a bright one. With all the new technological advances, it'll be really promising to see what develops. One possibility is interactive remote sensing, which will allow the user to tag locations for certain attributes or conditions. So images have always been a really great tool used to study, explore, and to gain insights. So in the past, we really just had the telescopes that were helping us, and today we still use telescopes, but we're also taking these visual images that are delivered to us from robotic spacecraft in distant space. And these images have really transformed our understanding and revealed diverse, complex environments throughout our solar system. So this image here was taken for the first landing of the moon, and we can kind of see that it's a rocky, dusty planet. And this is the very first image taken from the Mars rover on the surface of Mars. And last but not least, this image shows us the existence of extraterrestrial water on Europa, which is one of Jupiter's moons. For the future, I think our images will continue to improve, and who knows, maybe even like a 3D or virtual reality type photo will be on the horizon and give us an even greater look at distant geological reasons. So currently we send rovers and spacecraft to travel and obtain data in all of the distant space exploration missions. This is due to many different factors. Just to name a few, We currently don't have a way to replenish consumable resources to far distances beyond the established space stations. Space exploration is really not cost effective. In fact, it costs roughly $10,000 to get a single pound of mass into low Earth orbit. And currently, spacecraft power systems degrade over time, so as time passes, the amount of power that's available to use actually reduces as time moves forward. Here are the references used in today's presentation. Thank you so much for watching.